ESN can provide the grower a significant return on investment, ROI, when properly used. Depending on the crop and local conditions, the return to the grower ranges from 0.5 to greater than 10 times the cost of ESN. By using simple calculations based on a set of agreed-upon assumptions, you can demonstrate to your customers just how much ESN could benefit them. To help you get started, we've provided data from a variety of studies using ESN on corn, wheat, and potatoes. For our first example, we'll use a simple comparison of ESN and urea, both applied before planting. In 4 years of an Illinois study, pre-plant urea averaged a yield of 123 bushels per acre. ESN applied in the same manner averaged 138 bushels per acre for an advantage of 15 bushels per acre. If the corn price is $3.50 per bushel, the increase in gross revenue is 15 bushels per acre times $3.50 per bushel, or $52.50 per acre. The N rate used was 150 pounds N per acre. The difference in cost between urea and ESN is typically about 20 cents per pound of N. So, at this price, the additional cost of using ESN instead of urea is 150 pounds of N per acre times 20 cents per pound of N, or $30 per acre. The net gain to the farmer from using ESN is $52.50 per acre greater revenue minus $30 per acre greater cost, or $22.50 per acre more profit for the farmer. The farmer's return on investment, or ROI, is the profit increase, or $22.50 per acre, divided by the cost of ESN to obtain the profit increase, $30 per acre. 22.5 divided by 30 equals 0.75. The farmer's ROI is 0.75, or 75 cents in net profit returned for each dollar invested in ESN. The next example is a wheat study from Saskatchewan. Based on the results of this study, we will use the following values. ESN produced a yield of 90 bushels per acre. Urea yield was 84 bushels. N rate was 75 pounds of N per acre, a wheat price of $4 per bushel. This calculation is the same as the Illinois corn example. The yield difference is 6 bushels per acre times $4 per bushel, for an increase in revenue of $24 per acre. The additional cost of ESN is 75 pounds of N per acre times 20 cents per pound of N, or $15 per acre. The farmer's profit increase is $24 per acre minus $15 per acre, or $9 per acre more profit. The ROI is therefore 9 divided by 15, or 0.6. The farmer makes 60 cents more profit for each additional dollar spent on ESN. Now let's take a look at a more complicated example. In a Nebraska corn study under leaching conditions, the recommended N application was a split application of N at a total of 175 pounds of N per acre, which was applied as UAN. This treatment averaged 180 bushels of corn per acre over the 3 years of the study. ESN applied in one pre-plant application averaged 197 bushels of corn per acre at 150 pounds of N per acre. The yield increase with ESN is 17 bushels per acre with 25 pounds less N per acre. ESN was also applied in only one application versus 2 applications for the recommended UAN application. So the values we will use in this calculation are a yield difference of 17 bushels per acre, N rate for UAN of 175 pounds N per acre and 150 pounds of N per acre for ESN, an application cost of $6 per acre for both materials, a corn price of $3.50 per bushel, and a difference in cost between ESN and UAN of 15 cents per pound of N. UAN typically costs a little bit more per pound of N than urea, although this can vary. Using these values, the increase in total revenue is 17 bushels per acre times $3.50 per bushel, or $59.50 per acre. In this example, calculating the costs is more complicated. We will assume UAN costs 50 cents per pound of N, so ESN, 15 cents more, will be 65 cents per pound of N. The total cost for UAN is therefore 175 pounds of N per acre times 50 cents per pound, or $87.50 per acre. The total cost for ESN is 150 pounds of N per acre times 65 cents per pound, or $97.50 per acre. The difference in cost is then $97.50 minus $87.50, or $10 per acre more for ESN. We also have to add an additional application to the cost of UAN because it was applied in 2 applications. This makes the total difference between the recommended UAN treatment and the ESN treatment $10 per acre minus $6 per acre, or $4 per acre. We can now calculate the increase in profit from ESN. The increased revenue for the crop is $59.50 per acre. The profit increase is then $59.50 per acre minus $4 per acre in increased costs, or $55.50 per acre more profit for the grower. The ROI is $55.50 divided by $4, or 13.88 to 1. That means this ESN program returned almost $14 profit per acre for every extra dollar spent on the ESN. A very good value indeed. Finally, we'll finish with one example from a different crop, potatoes. This example is based on a Minnesota potato study. In this study, one application of ESN at 200 pounds of N per acre yielded 602 hundredweight per acre, or CWT. 6 applications of urea at the same rate yielded 567 CWT per acre, or 35 CWT less than ESN. The typical farmer practice in this area is to apply 2 applications mechanically and the remainder as UAN through the pivot in multiple fertigation applications. In the research, 6 applications of urea followed by irrigation were used to simulate multiple fertigation applications. We know there is some additional labor and equipment required to apply N through the irrigation system, but this is very difficult to estimate. For the purposes of illustrating the calculations in this example, we will simply treat this as 6 applications of urea, although we realize this is not exactly the farmer's practice in reality. We will use the following values: potato price of $6 per hundredweight, ESN price of 20 cents per pound of N more than urea, application cost of $5 per acre. The difference in revenue is 35 hundredweight per acre times $6 per hundredweight, or $210 per acre. At 200 pounds of N per acre, the increased cost of ESN is $40 per acre, but ESN is applied 5 fewer times than urea, so the application cost savings is $25 per acre. So the net difference in cost is $15 per acre more for ESN than for 6 applications of urea. The farmer's increased profit is $210 per acre minus $15 per acre in cost, or $195 per acre more profit. The ROI is therefore 195 divided by 15, or 13. The examples illustrate how to calculate simply the value of ESN. They also show what a great value ESN can be to the grower by improving N-use efficiency. Better N-use efficiency means better crop performance and more money in the farmer's pocket. The dealer also benefits because of the greater margin for ESN than for traditional nitrogen fertilizers.